Let's do the homework for Chapter 6. Number 1. A company selling clothing on the internet reports that the packages it ships have a median weight of 68 ounces and an IQR of 40. The company plans to announce a sales flyer weighing 4 ounces in each package. What will the new median and IQR be? Well, because we're adding a constant value of 4 ounces to each and every data value, your new median weight simply shifts by 4 ounces for a new median weight of 72 ounces. Now, for your IQR, we're only adding a constant value here, so your range doesn't, so your spread doesn't actually change, meaning your IQR remains at 40 ounces. Part B reads, if the company recorded the shipping weights of these new packages in pounds instead of ounces, what would the new median and IQR be? Meaning, all you have to do is divide 72 and 40 by 16. And remember to write it as pounds, not ounces. Meaning, your median now is 4.5 pounds. And your IQR is 2.5 pounds. Next question, number 5. SAT or ACT? This question wants you to compare ACT scores collected by an admissions officer at a college and turn them into their SAT equivalents. We're given a lowest score of 19, a mean of 27, a standard deviation of 3, a third quartile of 30, median of 28, and an interquartile range of 6. To find the equivalent SAT score, simply follow the formula given to you in the question of SAT score equals 40 times the ACT plus 150 for each value, meaning your new lowest score is 910. Your new mean score for the ACT equivalent is 1,230. Your standard deviation for the scores is 270. Your new third quartile score is 1,350. Your new median is 1,207 or 220. And your new IQR is 390. On to the next question, number 7. Suppose your stats professor gives us test grades as z-scores and you get a 2.2. What this means for you as a student, you can write as 2.2 2 means I scored 2.2 standard deviations above the average score for this test. Okay, next one. Number 8. One of the authors has an adopted grandson whose birth family are very short. After examining him at his 2-year checkup, the boy's pediatrician said that the score for his height relative to American 2-year-olds was negative 1.88. What does this mean exactly? Well, in this case, it means that their grandson's height is 1.88 standard deviations below the average height of American 2-year-olds. Meaning he is quite short. On to the next question. Number 13. We're combining 2 test scores, 1 exam with a mean of 65 and a standard deviation of 10 points, a second exam with a mean of 80 and a standard deviation of 5 points. So you can sketch this out just to help you visualize it a bit better. Exam 1 had a mean of 65 with 10 points for the standard deviation. So you write it as 65 75 85 95 55 45 and 35 for the first test. And the second test you can sketch out with a median score, or with a mean score of 80 and a standard distribution and a standard deviation of 5 points for 85, 90, 95, 75, 70, 65. Now, on these 2 tests, Sarah scored an 88, Julie scored a 70 on the first test and a 90 on the second. So you can write her down as Julie being right here and a 90 on the second test. So Julie scores right here. Derek scored an 80 on both tests, placing him here and here for test 2. They both totaled 160 points on both of their exams, but Julie claims that her total is better. To see why she claims this, look at where they place on the both tests. On test 1, Julie is 1/2 standard deviations away from the mean, while Derek is 1.5 standard deviations away. On test 2, Derek is at the mean, so he is no standard deviations away from the mean, while Julie is 2 standard deviations away, meaning that on both tests, Julie has a total separation from the average scores of 2.5 standard deviations, while Derek is only 1.5 standard deviations. Comparing these two numbers, it would be clear to see that Julie had a much better score overall, just on standard deviation alone, because it is 2.5 standard deviations away from the means to 1.5. On to the next question, number 19. Recall beef in exercise 17 that had a mean weight of 1,152 pounds with a standard deviation of 84 pounds. Part A reads, cattle buyers hope that yearling Angus steers will weigh at least 1,000 pounds. To see how much over or under that goal the cattle are, we could subtract 1,000 pounds from all the weights. What will be the new mean and standard deviation? The new mean weight, in this case, because we are subtracting a full constant value from each individual data value, will be 152 pounds for the new average, because we are only shifting our data but not changing it. The second part of part A asks what the new standard deviation would be after doing this. As it turns out, the new standard deviation remains at 84, meaning it is unchanged because we are only shifting our data, not changing our spread. Part B reads, suppose such cattle sell at auction for 40 cents a pound. Find the mean and standard deviation for the sale price of all steers. In this case, all you have to do then is your mean of 1,152 times 0.4 for the 40 cents per pound to find a mean sale price of $460 with 80 cents. The second part of part B asks for the new sale price. The sale price is standard deviation. Just simply do the same thing again. Standard deviation of 84 times your 40 cents to find the new standard deviation to be 33.60. This is the end of the homework for Chapter 6. I hope it helped you all out, and we'll see you all in the next chapter.